Hi everybody, and welcome to our next Excel video. In this video, I want to show you how to find the variance and the standard deviation in Excel. And this is going to be a huge time saver for you. We've seen in class that computing the standard deviation and variance by hand is very, very time consuming. So there are some great formulas in Excel that we can use to get us that value very quickly. Standard deviation in particular is going to be something that we're going to use pretty much throughout the entire course. It's going to keep coming back over and over again. So if there is one formula that you know how to do in Excel, this should be the one. So I've already set it up, and we have our data set from a previous video on number of pets. It is sorted here, although it doesn't have to be sorted. So don't worry about if your data is not sorted. It doesn't matter for variance and standard deviation. Now, one thing I want you to notice is I do have it set up, but I do have it noted as population variance or sample variance and population standard deviation or sample standard deviation. There are different formulas if you have population data or if you have sample data. So it's extremely important when you're running these formulas that you understand which kind of data you have. I'll show you how to do both of them in this video. And I've just made up the data set, so it's pretty much irrelevant. We could pretend it's population data or we could pretend it was sample data. But in your homework and things, you want to be really careful. If you have population data, you need to use the formulas for population. And if you have sample data, you need to use the formula for sample. Same thing in the real world. If you had real data, you'd have to know which kind of data you have. And it's very important to note the difference. Basically, what happens is with population data, those formulas are being divided by n, or the population size, whereas in samples, they're being divided by n minus 1, or the sample size minus 1. And it's enough of a difference to usually cause an error if you don't use the right formula. So just watch out for those, or if you find your answers like really close to what it should be and you keep getting marked wrong, you may have used the wrong formula. All right. So let's say this data is population. So we're going to pretend that this is population data. Maybe I only surveyed like one class of students, and that's my whole data set. I don't want to look at any other classes. So I have population data here. Well, how do we find population variance? Like in all cases, we always start with an equal sign anytime we're doing a calculation in Excel. You can start typing in variance, and you'll see that there's a few things that pop up. You want to be really careful here. There's a lot of things that have to do with VAR or variance or covariance, and the one that we want is VAR.P for population, or we'll use VAR.S for sample in a little bit. So I click the one that says VAR.P. You also see little descriptions here of what each formula does, which is helpful. And I double click that. And then just like previous videos, we're just going to go ahead and hold my mouse down and select that data set. Once I've selected the data, I'm just going to go ahead and hit enter, and that is it. So again, this was called var.p, var for variance, p for population. If I want to find the standard deviation, again, we start with an equal sign. You can start typing in standard. You want to be careful. They use the abbreviation that I do in class as well, standard, so ST, DEV for deviation. These are your standard deviations in Excel. And again, there's lots of options. The ones that we're using are .P for population and .S for sample. You don't have to worry about any of the others. So if this is population data, I'm going to click the one that says .P. And again, then the process is the same. I'm just going to go ahead and select my data. Once I have the correct data selected, I'm going to go ahead and hit enter, and that would be the standard deviation for the population. So I guess I'll do all uppercase here, be easier to read, .P. So if you're doing a sample, we're going to do the same exact process, but we're going to use .S at the end. So always an equal sign whenever we're doing calculations or formulas, start typing in variance. And this time I'm going to pretend my data is a sample. So let's pretend that I want to survey, I don't know, all statistics students, and this is just a sample of them. I would click the .S one, but I still do the same process. I highlight my data set that I have. Once I have the correct data set highlighted, I'm just going to hit enter. And then I do the same thing here. Oop, I should have written this one right here. I'm going to hit equals. I'm going to start typing in standard deviation this time. And again, I want the .s for sample. And I'm going to highlight that data set. And then when I have it all correctly highlighted, I'm going to hit equals. So you can see there are some slight differences, right? In this one here for the population data, the formula is a little bit smaller because you're dividing by n, not n minus 1. So it's enough of a difference where if you're doing homework or if you're writing a presentation or report that you are going to get different answers. Your standard deviations tend to be a little bit closer. Remember that the standard deviation is just the square root of the variance. They're basically the same formula, but one is the square or square root of the other. And here, this case, they would both round to 2.6 if I round to the 10th position, so they're very close. But if I use the 100th position, I'd have 2.58 and 2.65. So again, they are different enough where they are wrong. It is wrong if you have the wrong formula. So just be really careful. And that's the biggest thing, is that the reader has to know the kind of data that they have. So Excel is a big calculator, but it's just a calculator. It will do whatever you tell it to do, and it does not understand population versus sample data, except for the fact that how to compute a formula. So the reader has to decide, okay, which kind of data do I have? And then make sure you use the appropriate formula there.